Okay, next is number 8. And number 8, if you look at your practice test, it says use the trapezoidal rule with n equals 4 to approximate the value of the integral from 0 to 4 of this function x squared minus 4x plus 8 dx. Show the rule. So n's going to be show the rule and the work. So n will be 4. So you could see that your interval is going to go from your. If you look at your integral over on your sheet there, it's going from 0 to 4. All right. So I'm going to have an interval of my b will be 4, my a will be 0, 4 minus 0 over n. H is n is 4. So that's just going to be 4 over 4 is 1. So h would be 1. And this is the trapezoidal rule. You want to state the rule. Trapezoid area, which is approximately the sum of all the trapezoids, is h over 2, and this is going to be y sub 0, 2y1, 2y2, 2y3, and 1y4. And these y's will be the values at the points over here, the different endpoints. This is going to be y sub 0, so I'm going from 0 to 4. So if you take a look at your interval over here, since I'm going from 0 to 4, these will be my y, x sub 0, x sub 1, x sub 2, x sub 3, x sub 4, and these are going to be the y's that go with those. So I'll have to put these numbers into my function. And remember, your function was x squared minus 4x. So this was the integral. I should write the integral over here so you can see the function. So it's the integral from 0 to 4 of x squared minus 4x plus 8 dx. All right? So I'm going to evaluate this function at these points 0, 1, 2, 3, 4. So I did that over here, actually show the work. I don't know if you can see that all right. But if I put 0 in here, I obviously get 8 because these 0 out. And then if I put a 1 in here, I get 1 minus 4 plus 8. 1 minus 4 plus 8, which ends up being 5. And then if I put 2 in here, I get 4 minus 8 plus 8, which is 4. And then for y3, I put 3 in the function. If I put 3 in the function, I end up with 9 minus 12 plus 8, which ended up being 5 again. And then if I put 4 in the function, I end up with 16 minus 16 plus 8, which is 8. So it's symmetrical. Is the parabola. And if I multiply these out, this is 8 plus 10 plus 8 plus 10 plus 8. And my h is 1, so it's going to be 1/2 times that. And then 3 times 8 is 24, plus 20 makes 44, so half of 24 is 22. That worked out nicely. Okay? So that's all you had to do using the trapezoidal rule. So that should be pretty easy. Just put those, just get your y values by putting your x values, get your 5 y values by putting your 5 x values into that function. All right. The next one, number 9. Okay, we just had to, we were given this information about these integrals. The integral, this is f of x, and g of x. So from 2 to 11, f of x is 6. From 2 to 7, f of x is negative 9. And from 2 to 7, g of x is 5. So we want to find the integral from 3 to 3 of g of x. Well, that's easy. That's just going to be 0. From 3 to 3 will be 0. We can just put that in right here. The integral from 7 to 2. Well, we know if the integral from 2 to 7 is negative 9, from 7 to 2, we'll just negate that. Then we'll reverse that, so that will make that just positive 9. So that's pretty easy. Remember, if you reverse the limits of integration, just change the sign. So if this is negative 9, if I reverse the limits of integration, this will be positive 9. 2 times g of x, well, I can just take this 2 out, and I can just say that's 2 times the integral from 2 to 7 of g of x dx. And I know that this integral is 5, so that's just going to be 2 times 5, or 10. Letter D, the integral from 7 to 11 of f of x, from 7 to 11. Now, this is a little trickier. All right. From 7 to 11. So I know if I go from 2, the integral from 2 to 7, plus the integral, and I'll just do it like this to save a little space, from 7 to 11, that equals the integral from what? from 2 to 11. I hope that makes sense. All right? If I go from 2 to 7 and then add that from 7 to 11, I get 2 to 11. Now what am I looking for here? I'm looking for 7 to 11. So if I have 7 to 11, if I subtract this, the integral from 7 to 11 will just equal the integral from 2 to 11 minus the integral from 2 to 7. That makes sense. If I take this area from 2 to 11 and I subtract the area from 2 to 7, I should get the area from 7 to 11. That's what I'm looking for, the area from 7 to 11. And what is the area from 11 to 2? That's 6. Minus, and then what was the integral from 2 to 7? Negative 9. So 6 minus negative 9 is going to be 6 plus 9, which is 15. So letter D was 15. Okay? Hope that makes sense. And then the integral from 2 to 7 of g of x minus f of x, well, that's just going to be, I've got 2 to 7 for both these, so g of x, that's just going to be the integral from 2 to 7 of g of x dx minus the integral from 2 to 7 of f of x dx. All right, these are all of our rules of integration. And the integral from 2 to 7 of g of x, from 2 to 7 of g of x was 5, minus, in the integral from 2 to 7 of f of x was negative 9. So 5 minus negative 9, which is the same thing as 5 plus 9, which is 14. So letter E was 14. So if you could see that, you could zoom in. I think that should work. Okay, so I hope that helps. All right, let's try number 10. We want to use Simpson's rule with n equals 4 to approximate the value of this integral from 0 to 4 of x squared plus 2 dx. So n equals 4, and I'm going from 0 to 4, so it looks like my h is going to be 1. So I think you can see this over here. This is number 10. Right here. So again, I'm going, these are my, let me move this over here so you see this. Okay, these are my points, y sub 0, I'm sorry, x sub 0, x sub 1, x sub 2, x sub 3, x sub 4. And my y will be the value of my function at those points. And my function was x squared. So again, this was the integral, I should write this over here, the integral from 0 to 4 of x squared plus 2 dx. All right, so let's take a look at that. So remember, this is your Simpson's rule, h over 2, y sub 0, 4y1, 2y2, 4y3, 1y4. All right, and these y values are going to be found by putting these x values, 0, 1, 2, 3, 4, into the function. All right, so if I put 0 in here, when x is 0, y is 2. When x is 1, I get 1 plus 2 is 3. When x is 2, 4 plus 2 squared is 4 plus 2 is 6. When it's 3, 3 squared is 9 plus 2 is 11. When it's 4, 4 squared is 16 plus 2 is 18. So these are the values that go in. 2, 3, 6, 11, and 18. I got these by putting these x values into the function to get my corresponding y values. And there's your y sub 0 and y sub 4. And remember, it's 2, and then 4 times that, 2 times 6, 4 times 11, and 18. So 4 times 3. And we multiply this, we get 2, 12, 6, 44, and 18. I can add these up, and it adds up ending up to be 88. And remember, it's h over 3. My h was 1 because I had 4 over an interval 4 and 4 subintervals, so 4 divided by 4 is 1, so it's h over 3 or 1 over 3. So it ends up being 88 over 3. So if you add all these up, you get 88. I think you could kind of work that out. You got a lot of 12s. That's 30, 74, 75, 76, 77, 78, 88. So you could do that in your head, 88 over 3. And you could leave it like that, improper fraction. Okay, so that's using Simpson's rule. And these are how you find your y's, by putting the values into the x. Remember, y equals, I could put this up here, y equals x squared plus 2. Okay? So not too difficult. I hope that helps.